This Camtasia video will be to talk about PERT. PERT is a method that was used by the Americans when the English invented, or the British invented, the critical path method. Where CPM, the critical path method, has definite times, the Americans decided that they couldn't be so sure, so they included an optimistic time, a pessimistic time, and a most likely time. A is the optimistic time, B is the pessimistic time, and M is the most likely time. And the standard deviation, or how variable, or how sure they are that the activity will be completed in time, is B minus A over 6. Now, to find the project completion time for any of the paths through the network, it's the sum of the expected times for each activity along the path that you're concerned with. This is the critical path here, but it could be for any of the paths. The project variance is the sum of the variances for the activities along the path, and in this case I've said the critical activity we're looking at. So we have an example with 6 activities. First, we're going to analyse using PERT so that we find the expected time, standard deviation and variance. Then we're going to calculate the probability that the project will be completed in 11 days. So if we look at the formula for the expected time and the standard deviation and put the numbers in for activity A, the optimistic time is 2, so A is 2. The pessimistic time is 10, so B is 10. And the most likely time is 3, so M is 3. If we calculate that, remembering that multiplication is done before addition, we get 4. For the standard deviation, this is B minus A over 6, so 10 minus 2 divided by 6 gives us 1.333. To get the variance, the relationship is just squaring the result. 1.333 squared gives us 1.778. If we now look at activity B, we have an optimistic time of 3, a pessimistic time of 5, and a most likely time of 4. Putting that into the formula, we have 3 plus 5 plus 4 lots of 4 divided by 6. And that gives us 4. For the standard deviation, we have pessimistic time minus the optimistic time divided by 6, pessimistic, optimistic, 6, giving us a third. Now, 0.333 squared is 0.111. Here is the completed table for all the activities. Now we need to draw the network to look at all the paths through the network. We can see that AD takes 10 time units, BE takes 11, and CF takes 12, and the critical path is CF being the longest path through the network. If we now look at the probability that one of the paths meets the deadline, starting with AD, and the deadline being 11, as this was given in the question, calculate the probability that the project will be completed in 11 days. That's your deadline. And we put this into the calculations for finding out the probability. First, we need the path. AD is 4 plus 6 from 4 here and 6 here. That's the expected time. The path variance is taken from the table earlier, where we have A is 1.778 and D is 0.111. So we have 1.78 plus 0.111. The standard deviation is the square root of the variance. So we now need to go back to the standard deviation. And the square root of 1.89 is 1.37. So if we now put this into the formula, this looks a little bit like the normal distribution formula. So you have your deadline, which is 11, your expected time divided by your standard deviation. So our deadline is 11, our expected time is 10, and our path standard deviation is 1.37. So we get a Z value of 0.73. If we look at this distribution, this normal distribution, our expected time is 10, our deadline is 11, and we want to know the probability is less than 11 days. That was what we were asked. Here, if we go to the tables, our tables show us the tail of the distribution. So then we have to do 1 minus that value to get the probability it's less than 11 days. So if we go on and have a look at 0.73 in the normal tables, we can see 0.7 here and 3 here gives us 0.2327. So the probability that it's more than 11 days is 0.2327, and the probability that it's less than 11 days is 1 minus 0.2327, which is 0.7673. So the probability that this path takes longer than takes less than the deadline is 0.7673. This is repeated for the critical path and also any other path through the network. And here we've got the critical path, which we got 0.29806. And the probability that the whole project will be completed in less than 11 days is the path AD probability, the path BE probability, and the path CF probability. Multiply those together, and that will give you your overall probability for the project being less than 11 days.